Hello and welcome. My name is Iris from the Australia University of Applied Science. We want to introduce you the Payback Tool, indeed an important tool for checking if the solar powered irrigation system will work profitably. You can find it in the Toolbox on the Energypedia website. The Payback Tool is part of the investment module. We open the tool and go first to the README side. This tool allows a comparative assessment between income and 3 different irrigation pumping options, namely solar, diesel, and grid connection. Information required for using this tool includes investment and operational costs for the different pumping system, anticipated income from agriculture production, and basic economic conditions, for example, inflation rate. An alternative tool can be found at the FAO website as indicated on this sheet. We go right away to the input side. Here we want to put in the data for Mary's farm from the country Cascade, Kenya, and start with the basic assumptions. As you can see, there is a lot of data to be filled in. In normal case, you will use the data from the farm or from your client. For our example, we took all of them from the Cascade, Kenya, as it can be found on the Energypedia website. The input required is explained for all the data. For example, the discount rate, that is the annual rate used to determine the present value of future cash flows, which is 16% in our case. There is no water levy in Kenya, for example, a surcharge for water utilization rights. The total maximum water pumped per day is 26 cubic meters as calculated in the water requirement tool. The gross farm profit per year is 270,770 Kenyan shilling per year as calculated in the farm analysis tool. The proportion of profit to invest is 100%. Let us go now to cost assumption for solar powered irrigation system. Data are from the country Cascade, Kenya, as all other data for this tool. The solar panels cost 400,000 Kenyan shilling and have a lifespan of 20 years. No price is given for the mounting structure. The total cost amount to 830,000 Kenyan shillings. The maintenance costs are given as 6,000 Kenyan shilling. Cost assumption for a grid-powered irrigation system are as follows. We use no inverter and no control unit. Electricity costs per year amount to 13,475 Kenyan shillings. These costs are calculated with assumptions as given on the lower right of this section. Maintenance costs per year amount to 5,000 Kenyan shillings. On the right hand side, you see that there is a CO2 emission table, and the grid-powered irrigation system produces 216 kg per year if we assume a grid emission factor of 0.332 kg CO2 per kilowatt hour. The last cost assumption is for a diesel-powered irrigation system. The generator costs are given in this case as 150,000 Kenyan shilling, and the generator has a lifespan of 3 years. This gives total costs for the investment of 510,000 Kenyan shillings. Fuel costs amount to 68,467 Kenyan shilling. These costs are calculated with assumption as given on the lower right of this section. The maintenance costs per year are 30,000 Kenyan shillings, which makes total costs per year of 98,467 Kenyan shillings.
If we look at the right side, we see that the diesel-powered pump emits 2,329 kilograms CO2 per year.
We go to the output sheet to see the results. If we look at the analysis of three options, we see right away red figures as a diesel-powered irrigation system. The internal rate of return value is below 0%, which means this option is not feasible. The same result is given by the negative net present value and also by the years of payback. The system capital and the operating expenses exceed income within 25 years. The bar diagrams below show the analysis for the three options graphically. Here we can see that the grid-powered irrigation system has a slight advantage over the solar-powered irrigation system. You can imagine that the comparison depends on the location of your irrigation project. But as a general rule, if there is a reliable grid electricity close by, it is usually the economically most viable option. Very interesting for the lending institution are the two last diagrams of the comparative accumulated income and system costs. We look first at the costs over the initial 10 years. We see that the grid-powered irrigation system is paid off in less than 2 years. The solar-powered irrigation system is paid off in 3.5 years. After 10 years, grid-powered and solar-powered irrigation system are pretty close, as you can see here. The situation for system costs over 25 years stay almost the same. The slope in between the horizontal plateaus and the curves can be explained by replacement costs for parts that have exceeded their lifespan. We can also see that after 25 years, the cost for the diesel-powered irrigation system exceed the accumulated income.